Good morning all, myself Nishmita. I am going to do presentation on sampling distribution and standard error. Before knowing about sampling distribution, we need to know some of the terms such as population, sample, parameter, statistics. Population typically refers the number of people in a single area, whether it be a city, town, region, country or the world. A sample is just a part of population and parameter are numbers that summarize data for an entire population, and statistics are numbers that summarize data from a sample. Next, meaning of sampling distribution. A sampling distribution refers to a probability distribution of a statistics that comes from choosing random samples of a given population. So, sampling distributions refers to a probability distribution of a statistics that comes from choosing or obtaining from a large number of samples drawn from a specific population. And the sampling distribution is further divided into three types. Under that, first one is sampling distribution of mean. The first and foremost type of sampling distribution is of the mean. So this type focuses on calculating the mean average of all sample means, which then lead to sampling distribution. The average of every sample is put together and a sampling distribution mean is calculated, which reflects the nature of the whole population. So with more samples, the standard deviation decreases, which leads to a normal frequency distribution or a bell-shaped curve on the graph. Next one is sampling distribution of proportion. When it comes to the second type of sampling distribution, the population samples are calculated to obtain the proportions of a population. Herein, the mean of all sample proportion is calculated and thereby the sampling distribution of proportion is generated. As the proportion of a population is defined by a part of the population that possesses a certain attribute, the sampling distribution of a proportion aims to achieve a mean of all sample proportion that involves the whole population. Next one, T distribution. Third of all, T sampling distribution is considered to involve a small size of the population that gives about no information about standard deviation. Under this type of sampling distribution, the population is very small that in turn leads to a normal distribution. The frequent distribution in this type is the most near to the mean of the sampling distribution. Only a handful of samples are far off from the mean value of the whole population. Next, we will discuss a small concept under sampling distribution, which is central limit theorem. The central limit theorem states that the distribution of a sample means approximates a normal distribution as the sample size gets larger. So regardless of the population's distribution, sample size equal to or greater than 30 are often considered sufficient for this central limit theorem to hold. So when the population is not normally distributed but the sample size is fairly large, which means greater than 30, then the sampling distribution will approach the shape of a normal distribution. If the population is normally distributed, then the sampling distribution would also be normal. So no matter what the sample size is. And the simple example of this is that if one flips a coin many times, the probability of getting a given number of heads will approach a normal distribution, with the mean equal to half of the total number of the flips. At the limit of an infinite number of flips, it will be equal to a normal distribution. The central limit theorem has several variants. In its common form is the random variables must be identically distributed. In variants, convergence of the mean to the normal distribution also occurs for non-identical distributions or for non-independent observation if they commonly live with the certain conditions. Next, we will see the characteristics of sampling distribution. Under that, first one is sampling distribution constitute the theoretical basis of statistical inferences and are of considerable importance in business decision making. So it is important in a business decision making. So, and also it is important in statistics because they provide a major simplification on the route to statistics. And it is usually a univariate distribution and closely approximate a normal distribution. And the sampling distribution depends on multiple factors: the statistics, sample size, sampling process, and the overall population. And it is used to help calculate statistics such as means, range, variances, and standard deviations for the given sample. Since populations are typically large in size, it is important to use a sampling distribution so that we can randomly select a subset of the entire population. Doing so helps eliminate variability when we are doing research or gathering statistical data. And it is also helps make the data easier to manage and builds a foundation for statistical inferencing, which leads to making inferences for the whole population. And understanding the statistical inferences is important because it helps individuals understand the spread of frequencies and what various outcomes are like within a data set. I would like to conclude this topic by saying that sampling distributions are effective tools used by researchers to make estimates and inferences about a longer or larger populations of interest based on the data that they have access to. So these sampling distribution data visualizations allow researchers that leverage them to make precise inferences and establish a stronger grasp on the understanding of population in general. In practice, one will collect sample data and from these data estimate the parameters of the population distribution. The most common measure of how much sample means differ from each other is the standard deviation of the sampling distribution of the mean. Next topic is standard error. The standard error is a statistical term that measures the accuracy with which a sample distribution represents a population by using a standard deviation. In simple word, we can say it as the standard deviation of the sample distribution is called the standard error. In statistics, a sample mean deviates from the actual mean of its population. This deviation is the standard error of the mean. So the formula for calculating standard error is standard error is equal to standard deviation divided by root n. Next, we will see why standard error matters. In statistics, data from sample is used to understand larger populations. Standard error matters because it helps us estimate how well our sample data represents the whole population. So, with the probability sampling, where elements of a sample are randomly selected, we can collect data that is likely to be representative of the populations. However, even with the probability sample, some sampling error will remain. That's because a sample will never perfectly match the population it comes from in terms of measures like means and standard deviation. By calculating standard error, we can estimate how representative our sample is of our population and make valid conclusion. And a high standard error shows that sample means are widely spread around the population mean. So, our sample may not closely represent our population. A low standard error shows that a sample mean are closely distributed around the population mean and our sample is representative of our population. So, if we decrease standard error by increasing sample size, using a large random sample is the best way to minimize sampling bias. Next, move to importance of standard error. Under that, first one is used in testing a given hypothesis. It is used an instrument in testing a given hypothesis. The hypotheses are generally tested at 5% level of significance. If the differences between observed and expected mean is more than 1.90 standard error, then we can say that the result of experiment does not support the hypothesis at 5% level. Next one is, it is helpful in understanding the unreliability of the sample. The standard error provides an idea about the unreliability of the sample, which means the greater standard error, the greater the departure of the actual frequency from the expected ones, and hence the greater is the unreliability of the sample. And next one is, with the help of standard error, we can determine the limits which the parameter values are expected to lie. So I would like to conclude by saying that standard error statistics measure how accurate and precise the sample is as an estimate of the population parameter. It is particularly important to use the standard errors to estimate an interval about the population parameter when an effect size statistics is not available. When the standard error increases, for example, the means are more spread out, it becomes more likely that any given mean is an inaccurate representation of the true population mean. And the standard error is a measure of dispersion similar to the standard deviation, and the standard error is not only the measure of dispersion and accuracy of the sample statistics, it is however an important indicator of how reliable an estimate of the population parameter the sample statistics is.